Hello everyone and welcome to our channel. In this video, we will be covering some important topics and questions related to those topics of the DEA C01 exam. You can find the complete PDF of this video and our practice exam questions through the link down in the description. We have more than 30 plus certifications and are here to help you achieve your certification goals. We will try to answer all of your doubts about the DEA C01 exam, such as the exam does not have any hands on lab or simulation type questions. There are no case study type questions in the exam. The exam duration is around 150 minutes, in which you have to cover 65 questions. The minimum passing score is 720 out of 1000. There is no negative marking in the exam. This certification will be valid for 3 years after you earn it. About the exam renewal process, you have to recertify. This video is a tutorial video and contains some practice questions for the DEA C01 exam. We will be covering these topics in this part of the video. However, these are not all the topics in the exam. As such, we will be publishing more parts to this series in the future. So please make sure to subscribe our channel and press the bell icon. To our first topic, AWS Glue. What is AWS Glue? It is a fully managed ETL service that allows you to easily move data between different data sources and targets. The key components are data catalog, a metadata store containing table definitions, job definitions, and other control information for your ETL workflows. Then we have crawlers, programs that connect to data sources, infer data schemas, and create metadata table definitions in the data catalog. Then we have ETL jobs, the business logic to extract data from sources, transform it using Apache Spark scripts, and load it into targets. And then we have triggers, mechanisms to initiate job runs based on schedules or events. Here we have a simple diagram showing how all these components come into play in AWS Glue architecture. Moving to the workflows, the typical workflow involves define data sources and targets in the data catalog, use crawlers to populate the data catalog with table metadata from data sources, define ETL jobs with transformation scripts to move and process data, run jobs on demand or based on triggers, and monitor job performance using dashboards. To the questions related to this topic, question 1. The company created an extract, transform, and load data pipeline in AWS Glue. A data engineer must crawl a table that is in Microsoft SQL Server. The data engineer needs to extract, transform, and load the output of the crawl to an Amazon S3 bucket. The data engineer also must orchestrate the data pipeline. Which AWS service or feature will meet these requirements most cost effectively? Here in this question, we have an ETL data pipeline in AWS Glue. The data engineer must crawl a table in Microsoft SQL and then extract, transform, and load the output of the crawl to an Amazon S3 bucket. The data engineer also must orchestrate the data pipeline, and the solution should meet these requirements most cost effectively. Considering all this, the most appropriate answer here is AWS Glue workflows. Thus, the correct option is B. In AWS Glue, you can use workflows to create and visualize complex extract, transform, and load activities involving multiple crawlers, jobs, and triggers. Each workflow manages the execution and monitoring of all its jobs and crawlers. As a workflow runs each component, it records execution progress and status. This provides you with an overview of the larger task and the details of each step. The AWS Glue console provides a visual representation of a workflow as a graph. Question 2. A data engineer is configuring an AWS Glue job to read data from an Amazon S3 bucket. The data engineer has set up the necessary AWS Glue connection details and an associated IAM role. However, when the data engineer attempts to run the AWS Glue job, the data engineer receives an error message that indicates that there are problems with the Amazon S3 VPC gateway endpoint. The data engineer must resolve the error and connect the AWS Glue job to the S3 bucket. Which solution will meet this requirement? Here in this question, the data engineering is configuring an AWS Glue job to read data from an Amazon S3 bucket. The data engineer has set up all the connection details and associated IAM roles. However, when the Glue job is run, the data engineer receives an error message that indicates that there are problems with the S3 VPC gateway endpoint. The data engineer must resolve the error and connect the AWS Glue job to the S3 bucket. Considering all these requirements, the most appropriate answer here is to verify that the VPC's route table includes inbound and outbound routes for the Amazon S3 VPC gateway endpoint. As such, the correct option is D. Question 3. A data engineer needs to schedule a workflow that runs a set of AWS Glue jobs every day. The data engineer does not require the glue jobs to run or finish at a specific time. Which solution will run the glue jobs in the most cost effective way? Here in this question, we have to schedule a workflow that runs a set of glue jobs every day. The glue jobs don't need to finish or run at a specific time. The solution must be most cost effective. Considering all this, the most appropriate answer is choose the Flex execution class in the glue job properties. Thus, the correct option is A. The Flex execution class in AWS Glue allows jobs to use idle resources within the Glue service, which can significantly reduce costs compared to the standard execution class. With Flex, glue jobs run when resources are available, which is a cost effective approach for jobs that don't need to be completed within a specific timeline. Question 4. A company stores daily records of the financial performance of investment portfolios in .csv format in an Amazon S3 bucket. A data engineer uses AWS glue crawlers to crawl the S3 data. The data engineer must make the S3 data accessible daily in the AWS Glue data catalog. Which solution will meet these requirements? In this question, the data engineer is using AWS Glue crawlers to crawl the data stored in .csv format in the Amazon S3 bucket. The S3 data should be accessible daily in the AWS Glue data catalog. As such, the solution that meets this requirement is create an IAM role that includes the AWS Glue Service Role policy, associate the role with the crawler, specify the S3 bucket path of the source data as the crawler's data store, Create a daily schedule to run the crawler. Specify a database name for the output. Thus, the correct option is B. Option B correctly sets up the IAM role with the necessary permissions using the AWS Glue Service Role policy, which is designed for use with AWS Glue. It specifies the S3 bucket path of the source data as the crawler's data store and creates a daily schedule to run the crawler. Additionally, it specifies a database name for the output, ensuring that the crawled data is properly cataloged in the AWS Glue data catalog. Question 5. A data engineer is building a data pipeline on AWS by using AWS Glue Extract, Transform, and Load jobs. The data engineer needs to process data from Amazon RDS and MongoDB, perform transactions, and load the transform data into Amazon Redshift for analytics. The data updates must occur every hour. Which combination of tasks will meet these requirements with the least operational overhead? Choose 2. Here in this question, the data engineer is using AWS Glue ETL jobs to create a data pipeline. The data engineer must process data, perform transactions, and load the transform data into Amazon Redshift for analytics. The data updates must occur every hour, and the solution should come with least operational overhead. Considering all these requirements, the most appropriate answers are configure AWS Glue triggers to run the ETL jobs every hour and use AWS Glue connections to establish connectivity between the data sources and Amazon Redshift. Thus, the correct options are A and D. Reduced code complexity. Glue triggers eliminate the need to write custom code for scheduling ETL jobs. This simplifies the pipeline and reduces maintenance overhead. Scalability and integration. Glue triggers work seamlessly with Glue ETL jobs, ensuring sufficient scheduling and execution within the Glue ecosystem. Pre-built connectors. Glue Connections offers pre-built connectors for various data sources like RDS and Redshift. This eliminates the need for manual configuration and simplifies data sources access within the ETL jobs. Centralized management. Glue connectors are centrally managed within the Glue service, streamlining connection management and reducing operational overhead. Question 6. A company uses an Amazon QuickSight dashboard to monitor usage of one of the company's applications. The company uses AWS Glue jobs to process data for the dashboard. The company stores the data in a single Amazon S3 bucket. The company adds new data every day. A data engineer discovers that dashboard queries are becoming slower over time. The data engineer determines that the root cause of the slowing queries is long running AWS Glue jobs. Which actions should the data engineer take to improve the performance of the AWS Glue jobs? Choose 2. In this question, the company is using QuickSight to monitor data, AWS Glue jobs to process data, and Amazon S3 bucket to store data. The company adds new data every day. The data engineer notices that the dashboard queries are becoming slower over time and determines the root cause to be the long running AWS Glue jobs. The solution should improve the performance of the Glue jobs. The most appropriate options are partition the data that is in the S3 bucket, organize the data by year, month, and day, and increase the AWS Glue instance size by scaling up the worker type. Thus, the correct options are A and B. About the options: A. Partitioning data in Amazon S3 can significantly improve query performance. By organizing the data by year, month, and day, AWS Glue and Amazon QuickSight can scan only the relevant partitions of data, which reduces the amount of data read and processed. This approach is particularly effective for time series data, where queries often target specific time ranges. And then B, scaling up the worker type can provide more computational resources to the AWS Glue jobs, enabling them to process data faster. This can be especially beneficial when dealing with large datasets or complex transformations. It is important to monitor the performance improvements and cost implications of scaling up. To our next topic, Amazon Redshift. What is Amazon Redshift? It is a fast, fully managed petabyte scale data warehouse service that makes it simple and cost effective to efficiently analyze all your data using your existing BI tools. It is optimized for datasets ranging from a few hundred gigabytes to a petabyte or more and costs less than $1,000 per terabyte per year, a tenth the cost of most traditional data warehousing solutions. Amazon Redshift Serverless lets you access and analyze data without all of the configurations of a provisioned data warehouse. Resources are automatically provisioned, and data warehouse capacity is intelligently scaled to deliver fast performance for even the most demanding and unpredictable workloads. You don't incur charges when the data warehouse is idle, so you only pay for what you use. Here you can see the data processing flow in Amazon Redshift. First of all, different types of data is ingested into an Amazon S3 bucket. Then it goes through data processing through a ETL engine, and then it reaches Amazon Redshift for data consumption. About its features, achieve best performance at any scale. It meets your needs for a highly scalable, performant, and reliable modern cloud data warehouse to handle growing data for any number of concurrent users. With the best price performance for your workloads, Amazon Redshift runs on massively parallel processing architecture and RA3 instances that separate compute and storage. Unify all your data with zero ETL approaches. Amazon Redshift employs a zero ETL approach that enable interoperability with integration between the data warehouse, your Amazon S3 data lakes, operational and NoSQL databases such as Amazon Aurora, Amazon RDS, and Amazon DynamoDB, and even your streaming data services, so that the data is easily and automatically ingested into the warehouse for you, or you can access the data in place. Maximize value with comprehensive analytics and ML. From executing SQL queries to building complex dashboards or near real time and Gen AI applications, Amazon Redshift makes it easy for you to analyze all your data and drive your business forward. You can spin up a Redshift serverless endpoint in seconds, use Amazon Redshift's query editor to load, analyze, visualize, and collaborate on your data across data sources. Innovate faster with secure data collaboration. In just a few clicks, multiple teams can read and update shared datasets and collaborate on up to date data across regions, accounts, and even third party data warehouses. Data sharing is centrally governed by AWS Lake Formation. Amazon Redshift enables fine grained access controls such as role based access controls, row and column level security, and an easy authentication experience with single sign on for your organizational identity, all provided at no additional cost to you. To the questions related to this topic, question 7: the company is building an analytic solution. The solution uses Amazon S3 for data lake storage and Amazon Redshift for a data warehouse. The company wants to use Amazon Redshift Spectrum to query the data that is in Amazon S3, which action will provide the fastest queries. Here in this question, Amazon S3 is being used for data lake storage and Amazon Redshift for a data warehouse. We must use Amazon Redshift Spectrum to query the data in Amazon S3, and the solution must provide the fastest queries. The most appropriate solutions are use a columnar storage file format and partition the data based on the most common query predicates. Thus, the correct option is B and C. About the options, B. This is an excellent approach. Columnar storage formats like Parquet and ORC are highly recommended for use with Redshift Spectrum. They store data in columns, which allows Spectrum to scan only the needed columns for a query, significantly improving query performance and reducing the amount of data scanned. Then we have C, partitioning data in S3 based on commonly used query predicates allows Redshift Spectrum to skip large portions of data that are irrelevant to a particular query. This can lead to substantial performance improvements, especially for large datasets. Question 8. Company maintains a Amazon Redshift provisioned cluster that the company uses for ETL operations to support critical analysis tasks. A sales team within the company maintains a Redshift cluster that the sales team uses for BI tasks. The sales team recently requested access to the data that is in the ETL Redshift cluster so the teams can perform weekly summary analysis tasks. The sales team needs to join data from the ETL cluster with the data that is in the sales team's PI cluster. The company needs a solution that will share the ETL cluster data with the sales team without interrupting the critical analysis tasks. The solution must minimize usage of the computing resources of the ETL cluster. Which solution will meet these requirements? Here, the sales team needs to join data from the ETL cluster with the data in the sales team's BI cluster. The company needs a solution that will share the ETL cluster data with the sales team without interrupting the critical tasks and must minimize usage of computing resources of the ETL clusters. Considering all these requirements, the most appropriate answer is set up the sales team BI cluster as a consumer of the ETL cluster by using Redshift data sharing. Thus, the correct option is A. Question 9. A financial services company stores financial data in Amazon Redshift. A data engineer wants to run real time queries on the financial data to support a web based trading application. The data engineer wants to run the queries from within the trading application. Which solution will meet these requirements with the least operational overhead? Here in this question, the data engineer wants to run real time queries on the financial data from within the trading application. The solution must meet these requirements with the least operational overhead. Considering these requirements, the most appropriate answer is use the Amazon Redshift Data API. Thus, the correct option is B. The Amazon Redshift Data API is a lightweight HTTPS based API that provides an alternative to using JDBC or ODBC drivers for running queries against Amazon Redshift. It allows you to execute SQL queries directly from within your application without the need for managing connections or drivers. This reduces operational overhead as there is no need to manage and maintain WebSocket or JDBC connections. Question 10. Company uses an Amazon Redshift cluster that runs on RA3 nodes. The company wants to scale read and write capacity to meet demand. A data engineer needs to identify a solution that will turn on concurrency scaling. Which solution will meet these requirements? Here we want a solution that will turn on concurrency scaling. As such, the correct answer is turn on concurrency scaling at the workload management queue level in the Redshift cluster. Thus, the correct option is D. Concurrency scaling in Amazon Redshift allows the cluster to automatically add and remove compute resources in response to workload demands. Enabling the concurrency scaling at the workload management queue level allows you to specify which queues can benefit from concurrency scaling based on the query workload. To the third topic, Amazon Athena. What is Amazon Athena? It is an interactive query service that makes it easy to analyze data in Amazon S3 using standard SQL. Athena is serverless, so there is no infrastructure to set up or manage, and you pay only for the queries you run. To get started, simply point to your data in S3, define the schema, and start querying using standard SQL. Amazon Athena also makes it easy to interactively run data analytics using Apache Spark without having to plan for, configure, or manage resources. When you run Apache Spark applications on Athena, you submit Spark code for processing and receive the results directly. Use the simplified notebook experience in Amazon Athena console to develop Apache Spark applications using Python or Athena Notebook APIs. About its features: serverless, zero infrastructure, zero administration. You don't need to worry about configuration, software updates, failures, or scaling your infrastructure as your datasets and number of users grow. Athena automatically takes care of all of this for you so you can focus on the data, not the infrastructure. Easy to get started. To get started, log into the Athena console, define your schema using the console wizard or by entering DDL statements, and immediately start querying using the built in query editor. You can also use AWS Glue to automatically crawl data sources to discover data and populate your data catalog with new and modified table and partition definitions. Results are displayed in the console within seconds and automatically returned to a location of your choice in S3. Flexible pricing. It offers two flexible pricing models. By default, queries are built based on the data scanned per query in terabytes. This allows you to submit queries without planning ahead for compute. If you prefer to pay based on the compute your queries consume or want to control concurrency and prioritize workloads, use capacity based pricing available with provisioned capacity. For added flexibility, you can use per query billing and capacity based pricing at the same time in the same amount. Fast performance. With Amazon Athena, you don't have to worry about managing or tuning clusters to get fast performance. It is optimized for fast performance with Amazon S3. It automatically executes queries in parallel so that you get query results in seconds even on large datasets. Highly available and durable. It is highly available and executes queries using compute resources across multiple facilities, automatically routing queries appropriately if a particular facility is unreachable. It uses Amazon S3 as its underlying data source, making your data highly available and durable. Amazon S3 provides durable infrastructure to store important data and is designed for durability of 99.99% of objects. Your data is redundantly stored across multiple facilities and multiple devices in each facility. Machine learning. You can invoke your SageMaker machine learning models in an Athena SQL query to run inference. The ability to use ML models in SQL queries makes complex tasks such as anomaly detection, customer cohort analysis, and sales predictions as simple as writing a SQL query. Athena makes it simple for anyone with SQL experience to run ML models deployed on Amazon SageMaker. 2D questions related to the same topic. Question 11. A data engineer needs Amazon Athena queries to finish faster. The data engineer notices that all the files Athena queries use are currently stored in uncompressed .csv format. The data engineer also notices that users perform most queries by selecting a specific column. Which solution will most speed up the Athena query performance? Here in this question, we want to speed up our Amazon Athena queries. All the files used by these queries are stored in an uncompressed .csv format, and the users perform most queries by selecting a specific column. As such, the most appropriate solution to speed up these queries is change the data format from .csv to Apache Parquet, apply snappy compression. Thus, the correct option is C. Apache Parquet is a columnar storage format optimized for analytical queries. It is highly efficient for query performance, especially when queries involve selecting specific columns, as it allows for column pruning and predicate pushdown optimizations. Question 12. A data engineer needs to join data from multiple sources to perform a one time analysis job. The data is stored in Amazon DynamoDB, Amazon RDS, Amazon Redshift, and Amazon S3. Which solution will meet this requirement most cost effectively? Here in this question, the data engineer needs to join data from all these sources to perform a one time analysis job. As such, the most appropriate answer here is to use Amazon Athena Federated Query to join the data from all data sources. Thus, the correct option is C. These were all the topics and questions for this video. You can find the complete PDF of this video and our practice questions through the link down in the description. Please make sure to subscribe our channel and press the bell icon for the future videos. Thank you for watching and stay tuned.